Hello there. Welcome to the Technovation podcast. Thanks for joining us.
All right, let's really unpack something we all feel. AI, I mean, it's truly transforming everything around us, isn't it? From like the personalized recommendations you get to how we interact with our phones. It's just constantly reshaping our world. But here's the thing, behind every single one of those intelligent systems, there's a human mind, a creative force actually shaping it.
That really is the crucial. It's so easy to focus on the tech itself, right? And forget the brilliant people behind the algorithms, the data pipelines, the models that make it all possible. They're kind of the architects of what's coming next.
Totally. And if you've ever wondered, who actually builds these incredible systems, or maybe you've even thought about a career right there at the cutting edge of AI, then this deep dive is definitely for you. We're going to unpack the fascinating, often challenging, but really rewarding role of an AI engineer.
And our guide for today's deep dive, it comes from a really insightful roadmap called the Aspiring AI Engineer's Guide to Success. It's pretty comprehensive, looking at what it genuinely takes to, make it in this field.
So our mission today is to journey through this roadmap together. We'll start with the foundational skills, then kind of navigate through the really exciting stuff like machine learning and deep learning, all the way through to real-world deployment and, how you actually grow a career in AI. Think of it as a shortcut, maybe, to understanding the essential skills, the sometimes surprising realities, and the huge future potential here. Let's dive in. Okay, so let's start right at the beginning. When we talk about an AI engineer, what are they doing day to day? And how is that fundamentally different from, say, a traditional software programmer?
Well, at its core, an AI engineer builds intelligent systems that can learn, reason, and adapt. The key difference from a traditional programmer is pretty profound, actually. And a programmer explicitly codes every single rule, every instruction. But an AI engineer, they teach machines how to learn from data, how to improve on their own. It's really a shift from direct instruction to, cultivating intelligence.
That's a huge difference in mindset, yeah. So they're not just writing endless if-then statements, they're building systems that kind of figure those out themselves. What does that mean for their actual job, like their day-to-day? What are the main responsibilities?
Their core responsibilities, they cover a pretty wide range. They're designing and training these sophisticated machine learning and AI models, for sure. But just as crucially, they're building and managing the complex data pipelines that feed those models. That's huge. And here's where the engineer part really comes in. They have to deploy those models into real-world applications, make sure they run efficiently, scalably.
Wow, that sounds like a really unique blend of skills. It's like you need to be part researcher, part builder.
You absolutely do. The guide uses a great analogy. Think of an AI engineer as both a scientist, someone researching algorithms, understanding the deep principles, and an engineer, someone building robust, reliable products that actually work in the real world. It's that mix of theory and practice that makes the role so challenging, but also so impactful. And honestly, it's why they're so critical now. These are the folks quietly shaping our daily lives, from streaming recommendations to the smart and advanced robotics.
All right, so with that clear picture of the role, let's talk foundations. The bedrock everything else is built on. The guide really hammers home that AI is fundamentally built on math. Now, for a lot of people, that sounds intimidating, like you need to be a math genius. Is that really true?
Not really, no. I mean, AI is deeply mathematical, but you don't need to be a theoretical mathematician proving theorems all day. What's really crucial is understanding the concepts, the intuition behind certain areas like linear algebra. It's basically the grammar of AI, right? It's how models see and manipulate data, finding patterns in numbers that we just can't spot.
Okay, so it's less about the super complex proofs and more about understanding the mechanics, how it works.
Exactly.
What other math areas are essential then?
You'll definitely need probability and statistics. That's how models handle uncertainty, update their beliefs with new data, think Bayes' theorem, helping them make better guesses. Calculus is vital too. It's the engine of learning, really. Allows networks to optimize, improve through things like gradients, derivatives, especially in backpropagation. And discrete math is key for understanding the logic, the flow, the connections within algorithms, like a map for data structures. The guide even suggests a pretty clear study path. Start with Khan Academy for basics, maybe move to Gilbert Strang's linear algebra book, and then the Mathematics for Machine Learning book is great too.
That's a fantastic, really actionable path. Kind of demystifies the whole math requirement thing. Of course, math is only one side. What about the programming, the actual tools you need?
Yet strong programming skills are absolutely paramount. And Python, well, Python is basically the main language of AI now. Pretty much all AI research, most real-world jobs, they use Python. So you need to get good with the essential libraries. NumPy for numbers, Pandas for handling data, Matplotlib for making charts, and scikit-learn for traditional machine learning stuff.
And what about the really advanced AI models, the ones powering things like, ChatGPT or DALL-E? What tools enable those?
Right, that's where deep learning frameworks come in. TensorFlow and PyTorch are the big ones. They give you the tools to build and train those really complex neural networks efficiently. Beyond Python itself, SQL is pretty crucial for getting data out of databases. And Git plus GitHub, that's just indispensable for version control, working with others. Oh, and Jupyter Notebooks are great for experiments, trying things out. The main tip here, learn Python deeply. Don't just scratch the surface.
That really clarifies the toolkit. It shows that, with a structured approach, these foundational skills are definitely within reach, whether you're a coding veteran or just starting out. All right, so foundations laid. How do we start building the actual intelligence? What are the core AI skills you dive into first? Machine learning, maybe?
Yeah, machine learning, or ML, is usually the starting point. That's where models begin learning patterns and making predictions directly from data. The guide breaks it down into supervised learning, which is kind of like teaching with flashcards, right? You give it labeled data input and correct output, and it learns the mapping. That covers things like linear or logistic regression, predicting house prices, for example, or decision trees and SVMs for classification tasks, like figuring out if an email is spam.
Okay, and then there's unsupervised learning, where the data isn't labeled. How does that work?
Exactly. With unsupervised learning, you're basically telling the machine, here's a bunch of data. Find interesting structures or patterns yourself. No labels provided. So this is for tasks like clustering, grouping similar things together. Algorithms like k-means or dbscan do this, or dimensionality reduction like PCA, which helps simplify complex data. Really useful for things like customer segmentation, finding natural groups you didn't know existed.
Gotcha. So once you've trained a model, how do you actually know if it's any good? How do you measure if it's working?
Good question. That's where model evaluation metrics are key. You use things like accuracy, precision, recall, F1 score, ROC curves, a whole toolkit, really. These help you understand how well it's performing, not just if it's working. And techniques like cross-validation help ensure your results are reliable. And one more thing in ML feature engineering, this is super important, often overlooked. It's the art, really, of pulling out the most meaningful signals, the best features from raw data. It's like transforming messy information into gold that your models can actually learn from effectively. So ML is about teaching machines rules from data. Deep learning, or DL, is often called the brain behind modern AI. This is where things get really exciting, really powerful.
Okay, yeah, now we're getting into the tech that powers the stuff making headlines every day, right? So what are the core ideas in deep learning?
At its heart, DL uses neural networks. These are structures inspired, loosely, by the human brain. They learn through processes like forward propagation data flowing through the network and backpropagation. Backprop is kind of the magic sauce. It lets the network learn from its mistakes, basically, by adjusting its internal connections based on how wrong its predictions were. It's iterative learning.
And I guess there are different types of these networks specialized for different kinds of data.
Precisely. You've got convolutional neural networks, CNNs, they're the champs for image and video stuff, understanding visual data. Then there are recurrent neural networks, RNNs, and their more sophisticated cousins, LSTMs. They're great for sequential data, like text, speech, or time series analysis. And then transformers. These are the real game changers, especially in natural language processing. They're behind the super powerful models like BERT and GPT everyone's talking about.
Ah, the giants. Okay. And what about generative AI, the stuff that creates new images or text?
That also falls under deep learning. Technologies like GAN's generative adversarial networks and, more recently, diffusion models. They allow for that incredible generation of images, video, even music, often just from a text prompt. So with DL skills, you could build projects like, say, an image classifier for cats versus dogs, analyze text sentiment, or maybe even build a basic chatbot. Lots of cool possibilities.
Speaking of text, that leads us perfectly into natural language processing, NLP. What does that involve for an AI engineer?
NLP is all about getting computers to understand, interpret, and even generate human language. It's a huge field. Key parts include text preprocessing, that's like cleaning up the raw text, breaking it into words, tokenization, maybe simplifying words, stemming, and then using powerful language models, things like Word2Vec, GloVe, again, Transformers are dominant here to represent words and sentences numerically, capturing meaning and context.
And the applications for NLP seem to be everywhere now.
Oh, absolutely. Think about chatbots getting smarter, tools that automatically summarize long documents, real-time language translation, even sentiment analysis tools that can tell you the overall feeling of, say, thousands of customer reviews.
Okay, last core discipline. Reinforcement learning, RL. This one always feels a bit sci-fi, the AI learning by doing.
It kind of is. RL is like learning through trial and error, but for machines. You have an agent, the AI interacting with an environment. It takes actions, gets rewards or penalties, and learns over time to choose actions that maximize its total reward. Think training a dog with treats, but mathematically. Key algorithms here include things like Q-learning and deep Q networks, or DQNs.
And the applications are really cutting edge, right? Robotics, self-driving cars, game-playing AI. So it's literally teaching an AI to operate effectively in some world.
Yes, exactly. The guide even suggests a fun project. Training an AI to play a simple video game. That's a classic RL task. So yeah, this whole section really shows the sheer breadth and excitement of AI applications connecting these technical skills to real-world intelligent systems. Okay, so we've talked about all these cool models, these algorithms, but here's the really crucial point, maybe the surprising bit for some. AI systems. They are only as good as the data you feed them. This is where data engineering and building solid data pipelines become just absolutely critical, non-negotiable, really.
That's such an important point and probably overlooked a lot, right? People see the fancy model, but the data, that's the actual fuel. So what does that data journey typically look like for an AI engineer?
Well, it's often a pretty complex path. It starts with data collection, maybe pulling data from APIs, scraping websites, getting feeds from IoT devices, tons of sources. Then comes the really hard part, often, data cleaning. You're dealing with missing values, duplicates, noisy data, inconsistencies. It can be a real mess.
And you can't just use Excel for the massive data sets AI often needs, right? You need specialized tools.
Definitely not Excel. For large-scale stuff, you're looking at big data tools like Spark or Hadoop. They're designed to handle massive amounts of data efficiently. And then you need to build ETL pipelines. That stands for extract, transform, load. These are automated processes to get raw data, clean it up, transform it, and load it into a place where your models can use it.
This sounds intensive, like a lot of work before you even get to the modeling part. How much time are we talking?
The guide gives a number that usually surprises people. Expect to spend maybe 70 to 80% of your time just on data wrangling, cleaning, preparing, managing data.
Wow, really? 70 to 80%? That's way higher than I think most people would guess.
It is. It really highlights that AI isn't just magic. A huge chunk of it is this meticulous, often painstaking work on the data itself. It's the garbage in, garbage out principle, but on a massive scale.
Okay, that really drives home the importance of the data side. So after all that grunt work, getting the data pristine, building the model, the next big hurdle is making it actually work out there in the real world, right?
Exactly. That brings us to AI deployment and MLOps machine learning operations. This is all about taking your model from your laptop or a server and putting it into production where it can be used. So you need to figure out model serving. How do you make your trained model available? Often that means wrapping it in an API using frameworks like Flask or Fast API so other applications can call it.
And I bet there are specific tools and methodologies to manage this whole process because it sounds complicated.
Oh yeah, that's what MLOps is all about. Tools like MLflow or Kubeflow help streamline that whole lifecycle, tracking experiments, packaging models, deploying them, monitoring them. Containerization is also key here. Using Docker and Kubernetes lets you package your model and all its dependencies together, so it runs consistently anywhere, your machine, the cloud, wherever.
And then you actually need to put it somewhere people or systems can access it.
Right. Cloud platforms are huge for this. AWS SageMaker, Google Vertex AI, Azure Machine Learning. They provide the infrastructure and tools to deploy, manage, and scale AI applications effectively. And deployment isn't the end. Monitoring is critical. You have to keep tracking how your model is performing over time. Is it still accurate? Or is it suffering from model drift, where its performance degrades as real-world data changes?
So for someone just starting out feeling maybe a bit overwhelmed by all this, what's a good, simple goal they could aim for in this deployment space?
The guide suggests a really great starting point. Try deploying a simple machine learning model as a REST API. Then build a basic web app that actually calls that API to make predictions. It's a fantastic way to connect the dots, to see how AI goes from being code on your machine to something tangible, something interactive. Now, as these AI systems get more powerful, more integrated into everything we do, there's another layer that modern AI engineers absolutely have to think about. And that's the broader impact, the ethics, building responsible AI.
Yeah, this feels increasingly important. It's not just a technical job anymore, is it? It's got real societal implications. What are the main areas an AI engineer needs to consider here?
You're spot on. It's a fundamental part of the role now. First up is bias and fairness. We need to actively work to make sure our AI systems don't discriminate or perpetuate harmful societal biases. That often comes from biased training data, so you have to be really careful about that. Then there's explainability. Can you understand why your model made a certain prediction? Not just what it predicted. This builds trust and helps find problems. We need interpretable AI.
And with all the data involved, privacy must be a huge concern too. How do engineers tackle that?
Absolutely critical. Privacy is paramount. Techniques like federated learning are interesting models learned from data on local devices without the raw data ever leaving, or using data in automation to strip out sensitive info. And finally, something gaining more attention is sustainability. Training huge AI models takes a ton of energy, so thinking about energy-efficient models and the environmental footprint is becoming part of the job.
Can you give a quick, concrete example of this kind of ethical thinking in practice?
Sure. The guide mentions auditing a facial recognition system for bias. That means specifically testing if it performs worse for certain demographic groups, different skin tones, genders, ages. And if it does, actively working to fix that bias. It really highlights that critical human element. We have this powerful tech, we have to wield it thoughtfully, ethically. It's about what you should build, not just what you can.
That's a really powerful point. Okay, so we've covered the role, the skills, the data, deployment, the ethics. What about actually navigating the career path? How does someone grow and keep learning in a field that changes so darn fast? Let's talk portfolio first.
Yeah, building a portfolio is absolutely essential. It's how you show what you can do. So definitely create a GitHub profile, fill it with your AI projects, show the code, explain what you did. Publishing notebooks on Kaggle or Google Colab is great too. And maybe even write blog posts explaining your models, your process. It really demonstrates your thinking.
And it's not just about showing your work, right? Connecting with other people in the field seems huge too. Networking. Community.
Oh, crucial. Joining AI and ML groups like on Kaggle. Reddit has R Machine Learning, which is great. LinkedIn groups helps you connect, ask questions, learn from others. Attending conferences if you can, big ones like NeurIPS, ICML, CVPR is amazing for learning and networking. Even contributing to open source AI libraries is a fantastic way to learn, collaborate, and get your name out there.
And once you're sort of in the field, it helps to understand the different job titles, right? It's not all just AI engineer. Can you clarify those different tracks a bit?
Yeah, they can be a bit fuzzy sometimes, but there are distinctions. An AI engineer is often focused on building the applied AI systems, integrating them into products, getting it working end to end. An ML engineer might focus more specifically on building and scaling the machine learning pipelines themselves, the infrastructure, the ML side of things. A data scientist tends to lean more towards research and analysis, exploring data, finding insights, maybe building initial prototype models. And then a research scientist is usually pushing the boundaries, designing totally new algorithms, often in academia or large research labs.
That definitely helps clear things up. But regardless of the title, in a field moving this fast, continuous learning has got to be non-negotiable, right? It's like future-proofing your career.
It is the future-proofing strategy, honestly. AI evolves incredibly quickly. You just have to commit to lifelong learning. That means following new papers, maybe on our Hinsmo, reading AI blogs, experimenting with new frameworks as they pop up like JAX or libraries from Hugging Face. The landscape just shifts so fast. Curiosity, adaptability, they're essential traits.
And looking ahead, what are some of the exciting emerging areas people should maybe keep an eye on or start exploring?
The guide points out a few really interesting ones. Multimodal AI is big, combining different data types like images, text, audio for richer understanding. Think AI that can see and read at the same time. Edge AI, running AI models directly on your phone or small devices, not in the cloud. That opens up lots of possibilities for real-time private AI. And then further out, there's quantum machine learning. Still very early days, but it's exploring how quantum computing could revolutionize AI. Definitely the next frontier stuff.
Wow. This whole section gives such practical advice, but also paints a picture of just how dynamic and exciting this career path can be. Constant growth, constant adaptation. It's definitely a field for the curious. So, What an incredible journey today. We really covered a lot of ground. We started by unpacking what an AI engineer actually is, then dug into those crucial foundational skills, the math, the programming. Then we explored the core disciplines, machine learning, deep learning, NLP, reinforcement learning, seeing how they fit together.
And we didn't shy away from the often hidden reality of data engineering, spending all that time on data, plus the practicalities of actually deploying models with MLOps and the absolutely vital ethical side of building responsible AI.
Right. And we finish up looking at how to build a career, the importance of portfolios, networking, and that constant need for learning.
Yeah, if you boil it down, the action plans kind of get your Python and math basics solid, learn the ML fundamentals, build some models, then dive into deep learning, CNNs, RNNs, transformers especially.
Absolutely. And then crucially, build stuff. Projects are key. Think chatbots, image classifiers, maybe a recommendation engine. Learn how to actually deploy them using MLOps. Get that GitHub portfolio looking sharp.
And connect with people, join communities, and never ever stop learning. Stay curious about the latest research. It really is an adventure.
You know, the source material had this great line, success as an AI engineer doesn't come from knowing every algorithm. It comes from curiosity, persistence, and the ability to turn complex models into real-world solutions. And I think that connects to something bigger. The best AI engineers, they're just coders, are they? They're problem solvers. They're maybe even storytellers, shaping how this tech impacts us. Innovators. So maybe the question for you listening is, what kind of problems will you solve? What stories will you help tell? And what innovations could you bring to life as you engage with this amazing world of AI?
We really hope this deep dive has given you a clearer map, maybe some inspiration for your own journey into AI.
Thanks so much for joining us for this deep dive into the world of the AI engineer. Keep learning, keep building, and definitely keep exploring.
Till then, bye for now.